In this video, we're going to solve the following problem. We are given the graph of a trigonometric function, and we are asked to find an equation for this graph of the cosine form. So v is the velocity. It's a function of t, and we need to find something like this cosine function. bt, t is the variable, the time here. bt plus c plus d. This is the general form of a cosine function. The coefficient a, b, the constant c, and d are to be found. Now, before we start finding the values, let's develop some formulas. We know that the cosine function, this cosine here, has a maximum value of 1 and a minimum value of -1. Now let's put the formulas here on this side. So v, when v is maximum, v equal maximum a, when the cosine is equal to 1. So when this cosine is equal to 1, this v is maximum. So we say, let's say Vmax is a. Now v maximum is here. This is the value, and it's 1. Now let's go to v minimum. Now this expression here, the v is minimum when this is equal to -1, where the cosine is equal to -1. So v minimum, it's equal to a multiplied by -1. That gives me minus a plus d. Now this one here, we can take it out. So it's a plus d. Good. Let's add Vmax plus Vmin. Vmax plus Vmin, the left side. Now we add this side here. So a minus a goes, and that gives me 2d. That gives me the formula of d equal Vmax plus Vmin divided by 2. This is Vmin. Yeah, divided by 2. Good. So this is the first formula for d. Quite easy to implement. Now let's go back to this equation. Let's call them 1 and 2. Now let's subtract now. If we subtract, we will get Vmax minus Vmin, the left side. The other side will give me a plus d. And then I subtract minus a plus d. And when I do this, that will give me 2a. So 2a equal Vmax minus Vmin. A equal to Vmax minus Vmin divided by 2. These are the two formulas for a and d. Now Vmax is equal to 1. This is the maximum value. So we go here now. We say Vmax is equal to 1. Vmin, the minimum value of v, is what? Is 0. Okay, good. So d we said equal to what? Vmax plus Vmin. 1 plus 0 divided by 2. That gives me 0.5 A is assumed to be positive. It's Vmax minus Vmin. 1 minus divided by 2. 0.5. Of course, a here can be positive or negative. So we assume in our case it's positive. Good. So we found 2 already. Now let's go to find b. Now b is related to what? We know that the period of a trigonometric function, so let's call it p, the period is equal to 2 pi divided by b, assuming b positive. So you divide by b instead of absolute value of b when you don't know the sign of b. Now let's go and find the period from the graph. We need one period of which we know the end and the beginning. So for example, if we go from here to here, this is one period, from here to here. Now let's read. We are going from t equal to 0 to t equal to 3. This is one period. Now let's go here so it starts from here and finishes here. And then the period is the distance between 3 and 0. 3 minus 0. So the period is equal to 3 minus 0, and that gives me 3. I solve to find b equal 2 pi over 3. So we found 3 coefficients. Let's rewrite our function. V of t is equal to a. We found 0.5 cosine b 2 pi over 3 multiplied by the time t plus c plus d. Now we still need to find c. There are many ways to find c. The one I'm going to describe here, I'm going to present, it seems to me to be quite easy. Now, the way I'm going to find c, so we need to find c now. The way I'm going to find c is as follows. I'm going to go back to my graph. Try to locate either a maximum or minimum. Both ways it gives you the answer. Now, let's work with the maximum. The maximum seems to happen here somewhere between t equal to 2 and t equal to 2.5. It's somewhere in the middle. Now, if these points are not good enough, let's take this point and this point. So it's also in the middle between 3 and between 3 here and 1.5. So the middle of 3 and 1.5, the middle of 3 and 1.5 is calculated as follows by adding and then dividing. Now, if you do this, that will give you 4.25. So that means what? That means when t equals 4.25, v is equal to Vmax and is equal to 1. Let's go back to the graph. When t equal, hang on, I think we made a mistake here. Now, 4.25 I did not divide by 2, so it's 2.25. Okay. 2.25. When t equal 2.25, Vmax equal to 1. Let's go back and check. So somewhere between 2 and 2.5, 2.25, V is equal to maximum, and it's equal to 1. Good. Now let's go back to our equation and say that V is a maximum and is equal to 1. This V here is equal to 1 when t equal 2.25. So let's write this 0.5 cosine 2 pi over 3 multiplied by 2.25 plus c equal plus c plus 0.5. So what do we have? We have a trigonometric equation to solve. Here is c. Good. So that will give me 0.5 cosine 2 pi over 3 multiplied by 2.25 plus c is equal 1 minus 0.5 here. And then this gives me cosine 2 pi over 3 times 2.25 plus c equal to 1. Now the cosine is equal to 1 for many, many values. The cosine is equal to 1. That means this quantity here, 2 pi over 3 multiplied by 2.25 plus c is equal to k2 pi. So this problem has got many solutions, an infinite number of solutions. And of course k can be 0, plus minus 1, plus minus 2, and so on. Now this method is good because it allows you to find an infinite number of solutions and then select the one that they're asking you to find. Now here in this problem they are not asking, they're not putting any conditions, so I'm going to take k equal to 0. That will give me c, so k equal to 0. K equal to 0. That means c equal 2 pi over 3 multiplied by 2.25 and with a minus, yeah? So we are solving this equal to 0, and then it will give you this. Now let's write the 2.25 as a fraction. Okay, let's simplify this. C equal, now let's multiply 2 by 2.25. That gives me minus 4.5 divide by 3 pi, and this, when you divide, it will give you 1.5 pi, and it's equal to minus 3 pi over 2. 3 divided by 2, 1.5, and therefore our equation is written, the equation of the graph is written as 0.5 cosine 2 pi over 3 t. C, it's minus 3 pi over 2, that's what we found now, plus 0.5. So this is the equation that we found. We now show the graph of Vt, the graph of the equation that we found, using a calculator, and as we can see, it compares very well. It compares exactly with the one given to us.